Hi, everyone. I think we're live. I'm going to try to keep an eye on the chat this time, so you can let me know if the font size is too small. But I'm going to switch from the camera to screen share now. Nice. Cool. All right, I've cranked the resolution up to the biggest text I can give on Mac OS, so hopefully this will be big enough. Today we are going to take a look at the React DevTools profiler, and I thought it would be fun for us to sort of write a quote-unquote real-world app, and then look at some performance problems that you might encounter in actual, day-to-day code you're writing, and how we can spot them and how we can fix them. So first off, if you haven't seen this React blog post about the profiler, I'd encourage you to maybe pause this video if you're watching later. If you're live streaming, I'll try to explain as we go. But basically, we recently released a profiler for React that you can use to record performance information. And it gives you sort of insights into where your application is slow. So we're going to build on top of that. And for today's live stream, I thought it would be fun if we built a flame graph component. So for example, I've got a library called React Flame Graph, and we're going to build sort of a scaled down version of that. A flame graph is also what the profiler uses, so I thought this would be kind of a fun exercise. Basically, yeah, the way we're going to use this, take a look down here. The way that you configure a flame graph, or at least this one, is we'll take some data in that specifies a name for each node in the graph, and a value, which is, in this case, time, the milliseconds, and then some children, which are just a nested array of nodes. And we're also going to use another library of mine called React Window for performance purposes. So if you look at this flame graph, the nodes are pretty expensive, so we don't want to render all of them at once. And so windowing is a technique. React Window uses windowing. It's a technique for basically only rendering a slice of data. So in this case, based on where you scroll, we render just enough for you to for it to fill that part of the viewport without rendering things above or below. Okay, so for today's live stream, we're going to use create React app. Flame graph demo. And I'm going to be using Git as we go along, and I'll do some commits, and then when the video is done, I'll share a link to a GitHub repository of the code that we write in case you are interested in looking closer at anything, but maybe we didn't spend enough time on it during the live stream. And while this is installing, I'm going to check the comments to make sure there's no one saying that the font is too small. Okay, so far so good. Cool. So the first thing I'm going to do is, I guess I'll install first, and then I will commit the initial repo state. I'm also going to go ahead and install React Window and another plugin or NPM package that I created called Autosizer, which basically just stretches content to fill the available width and height, and I'll show how that's used in a minute. So I'll do another commit, install that. So you can see I did a dry run of this earlier, so I'm going to get some auto-completed commands from ZSH. Cool. All right, now we're ready to start. So I'm going to go ahead and take a bit of test data that's used to generate this chart from React Flame Graph, because it saves us time from writing some test data. So I'm going to put that in the public folder, and I'll call it data.json. Now the React DevTools profiler does not yet support profiling an application on startup. That's a feature that I'm planning to add, but what we're going to do for our initial app is sort of, we'll make a button that when we click, it runs the app, and that way we can start profiling before we actually run any code. So we'll go ahead and set that up first. So let's open our Flame Graph demo. And I hope this is big enough. I'll make it a little larger. I'm going to our app here, and we're going to add some state. And the state will be the data that we loaded to JSON. And we'll add a method called load data. And this method will fetch. And we called it data.json, so we'll fetch data.json. Then we'll convert it to JSON. And then we will put it in the state. And then down in our render function, we'll say, if we don't have data yet, then let's return a button. Otherwise, let's return just placeholder content for now. And then let's start it off. Okay. And I'm going to, from time to time, just be checking back to make sure no one's pinging me or let me know that there's a problem with the audio or anything. Cool. But here we have a button, and we load the data, and that comes from our JSON file. So far, so good. I guess next we will, okay, let's talk about the data that we're dealing with. So if you'll remember, the data coming in is going to be sort of this nested structure of name, value, and then an array of children. The way that a windowing library like React Window works, though, is you give it a number of items, and then it tells you, okay, render item at index 0 or index 100. And then you have to quickly be able to grab that data and render it. So this nested structure is no good for us because we would have to do a lot of traversal each time. So we're going to write a method that converts this data format to one that is a little easier for our app to work with. And the new format we're going to create is going to look basically like this. We'll have a, get some better syntax highlighting here. I'm not used to the font being quite this big. All right, we'll have a name, which will be a string. We'll have a width, which will be a number. And if we look at, take another look at a flame graph, we'll see that basically each item can have children, and then the children sort of stack from the left and fill up across the width of the parent. So for instance, this child is the exact offset of its parent, but this child is offset by the width of its the sibling that came before it. So we're going to need some sort of offset value to specify the position of the node. And then in our flame chart, we also have some color coding, which is nice. So let's add a color attribute, and I think that might be it. Okay. So let's write this function. We'll put it in utils. And the value we'll be passing in will be our root node. So we'll just call it root node. And then it's responsible to return a array of nodes that's been flattened down into this new structure that we just talked about. And the way that it will do that basically is going to be by crawling each node in our data structure and converting it to this new format, and then crawling its children. So I'm going to write a function called crawl, and it'll take a node and the array of return nodes for now. So we're first going to call this thing, and we'll say call the root node, and here's the other nodes that the flat nodes array. I guess maybe I'll just name this return array too to be consistent. Cool. And then we're going to want to convert it to the structure. Alrighty. So we'll make a converted node. So name is simple. That's just the same as the name of our other node. Value is interesting. So value is a number that represents time, milliseconds, seconds, whatever it is. And then we want everything in our flame graph to sort of start with the longest node, the root node, and then get smaller as they drill down. So, and we also want it to fill the width of the screen. And I'm going to check the chat here again. All good so far. Thank you. So this implies that we want everything to be relative to the widest node, which is the root node, and then we need to scale it up to fit the width of the browser at any given time. So we're going to scale, in other words, we're going to scale the width and offset to be 0 to 1 values relative to the width of the biggest node, which is the root node. So let's go ahead and also pass in what we're going to call max value. So the width of any particular node is equal to the percentage of its value that it fills up the max value. Similarly, we had said offset is sort of relative to both the parent. The first node underneath the parent has the same offset, but then other ones have an offset that's relative to the width of their siblings. So we're going to have to pass in something representing the offset as well. So let's call it parent offset. And for this first node, it's 0. And then color. All right, so color, we're going to use the same color scheme I used for React Flame Graph. And I built that, or I came up with that by plugging 2 colors that I think are pretty good for people with difficulty perceiving red-green color blindness. Instead, I think like the blue to yellow gradient is better from what I've heard and read. And so I used this cool color scale helper to generate an array of colors. And so we're just gonna store these. And the color of a thing will basically depend on how expensive it is in the overall flame graph. So like the most expensive things here are gonna be bright yellow, sort of a warm color, and then the least expensive things are gonna be a cool color. So we're going to say the color is equal to, again, the value. And then we're going to grab the corresponding index in the colored array. OK, so I think I might have made some mistakes, but I think this is basically how we will convert the nodes coming in to the nodes going out. And then we will need to do a couple of things. We need to put this node in the array. The array structure we have is going to be sort of a 2D array, where the outer array will be an item per row, and then the inner array will be the blocks within that row. So what we're going to do first is say, yes, one more thing we need to know is the actual depth of the item in the array. Cool. So we're going to say if, with the root node being at depth 0, so row 0. If we haven't yet initialized the array for this depth, we're going to add our converted node as the first entry. Otherwise, we will push it into the array. And then lastly, we'll say if our node has defined children, then let's crawl them too. And we'll say child, and we want to crawl this. So we will say your node is the child, the return array is the same. The depth, it's 1 level deeper in the tree, it's 1 row down. Max value is the same, and offset. So the offset starts as being the same as its parent, but then each subsequent child is offset by the width of its sibling. So we need to basically track and increment this value as we add children. So we'll initialize it to the parent offset, but then we need to bump it more by the child offset. So let's change this function to also return our converted node. And so we'll say we have a converted child, and then we'll say offset is offset by the converted child's width. And this will make sure that nodes start on the left and sort of grow out to the right. Okay. This, maybe this works, we'll see. Cool. Let's also take a stab at our flame graph component now. In chart. It'll take data in, and then it'll take a width and a height. And we're going to use React Windows, so let's come over here and just grab the boilerplate from the React window examples for now. It's going to be a flat list of a fixed height, so we'll do the same. Say our list data is going to be this conversion function that we just wrote. So we'll say import convert data. I think that's what I called it. Yeah. From utils, and then let's. I'm not going to format this. I'll let Pretty do it for us. Cool. And then we're going to use the height that we were told. The number of items in our array is just the number, or sorry, in our list is just the number of items in our flattened array. So we'll use that. The item size is the height of the item, and then our width. And then here, let's pull this out into its own function. And actually, we'll leave it in line for now, just like the doc show. OK, so React window gives you an index, which is the row you're supposed to render, and then a style, which does the positioning. So we're going to use the style as is. And then for the index, we will say, that our items are at the array of nodes in our item, and then we will map them out. Almost done, and then we'll have something that we can run and take a first look at, and hopefully I haven't totally messed up anything yet. We're just going to key to our index because this collection is stable. Items aren't going to be moving around, so that's OK. We'll add a style, and then we'll show the node.name. So remember, this is the data structure we're converting to. And let's also close this tag. We'll do a couple other things. I know that some of these nodes, if we'll look back at our flame chart, and let me check here again. OK, we're still good. Some of these nodes are tiny, and so we're going to want to show a tooltip on hover. So let's also add a title. And then let's fill in our style. So React window positions its children absolutely, each row. And so we're going to just position our columns within the row also absolutely. And so we'll say position absolute. Left is going to be the node offset relative to the width, so that we scale things up to fill the available width. And similarly, I'm just going to copy paste this. The width is going to be equal to the width. Height will be equal to our row height. And we'll go ahead and actually, I forget. I think it's fine if I just do number, but we'll also make the text line height the same so that it centers correctly. And then we will add background color equal to our node.color. And then we'll do, we also don't want these things to smash together, so I'm going to add a 1 pixel border to the right and bottom, and box sizing border box, which I wish was the default. OK, this might work. Let's try it and see. Oh, yeah, actually, I have to plug it in. OK, cool. So let's load our flame chart component from flame chart. And then if we have loaded our data, we'll say, here's your data. And then we also need to give it height and width. And this ties back into our auto sizer component that we installed at the start of the demo. So this comes from another NPM package that I released as a standalone thing. I don't have any example code. That's awesome. I should fix that. Anyway, the way it works is that you I'm going to import it. The way it works is that you put it somewhere in your tree, and it fills its container, and then it passes a child function that you provide it, a width and a height, and that is the width and the height of the parent container. So in this case, we're going to go ahead also into app.css really quick and make sure that we just fill 100% of the view width and height. And maybe, oh yeah, let's actually spell the word return correctly. Where is this? Flame chart. Oh yeah, okay, so this is reasonably close, but I forgot to handle overflow. All right, so maybe we have a flame chart now. Cool. We could pull the static pieces of style out. Let's go ahead and do that actually. We'll go ahead and pull the pieces of the style that are static out into our CSS file, and we'll call it node. And then we need to convert it from the JSX style format to CSS here. There's probably a plugin that does this for you that I should have used, but I didn't. And then back over here, I think we can now just say class name is node, and maybe this will give us cool. All right, so this is our initial boilerplate flame graph. And so I'm going to come back over to the command line and initial flame graph. Yeah, see, dry run, thank you. Yep, committed there. Okay, so now let's take a look at the actual, let's start actually using the profiler. And before I do, I'll double check here. Cool. No one's saying I can't hear you or I can't see you, so this is a good sign. Okay, let's open the profiler. So here it is. I have React DevTools installed. I'm running 16.5 of React DOM, so I see this new tab, which is the profiler. So I'm going to reload the page, click record, click load data, and scroll down a little bit. And let's see what we see. Here we can see that I just caused a bunch of renders, and here was our app when it was just a load button, and here was our app when I clicked load data, and it actually loaded the flame chart. And then as I scrolled, if you remember, because of how windowing works, which I might have closed that window. Anyway, the way windowing works is the React window is rendering a row for each of these. So it's rendering a row, just enough rows to fill the visible window. And then if we track this row, as it goes down, you can see that I'm popping rows off the top and pushing them on the bottom. So I would expect to see, as we scroll, only a couple of rows being added. But actually what we're seeing here is that we, every time the app renders, so like here's the list, we can see that as we step through, you can see the scroll offset is flashing. So this is, we're re-rendering because we're scrolling, but you can see that every row in the list re-renders, and we know that because they're not gray, they're blue. So the first thing we'll try to do is solve that problem. The reason for this, so I know this because I've built one of these things before, but the reason for this is that we're just using a function component. We don't have should component update, and so we're just re-rendering every time the parent component re-renders. So we can fix this by replacing our function component with a pure component. Let's do that really quick. So it'll be a little more verbose, but we'll get fewer renders every time we scroll. So in this case, it's probably going to be worth it because especially some of our lower rows, they have a lot of nodes, so we don't want to re-render these unnecessarily. All right, so have I made a typo? Because Prettier is not formatting this. There we go. Okay, so we get our style and our index from this.props instead of the inline function, but you'll notice that we're trying to read from list data, and we're also trying to reference width, and we don't have access to either one of those. So React Window provides a mechanism for this called item data. item data will pass an additional property to each item in the list, which is with just whatever you give it. So in our case, we're going to give it list data, and we're going to give it width. And then down here, we'll pull those values out again. Okay, so maybe this works. Okay, yeah, cool. All right, so I'm going to start profiling and load data, and then I'll scroll down. And hopefully, yeah, so we can see now as we scroll, sometimes when the scroll offset was too small, we won't re-render at all, except for the parent component, because it's, in this case, it's offset changed from 86 to 94, but that didn't actually change the visible number of rows. It did in this next scroll, and so you can see we're pushing, at most, one new item onto the end of the list, and then we're reusing all the ones before it. And I forgot to measure, let's do this. Let's stash this. And let's measure really roughly what our, so before, each time we scrolled, this was taking somewhere around 20-ish milliseconds. And if we profile after our change, hopefully we'll see a pretty good improvement. Yeah, so we see we're down to more like 1 millisecond. We have some noise here, which is probably a background process that's running or something, or maybe I scrolled really fast there. Let's do one more take here and see. Okay, yeah. So now we just saved a pretty big slice of time, in this case, by switching to pure component. So let's go ahead and commit this. That's all good. I do that a lot. Double check back here. Still, hopefully, no problems. Cool. So now this is like pretty good, but if you'll remember, we also built it so this component will resize to fill its available width and height. I guess one way to show this would be to open the Elements panel. And you can see right now it's rendering, what is this, 6 or 7 rows or something. As we resize, it renders more rows to fill the height. So let's profile and take a look at what that interaction looks like. Okay. So this is not great. What we can see is we're back to re-rendering all of the rows. So why is that? Let's look at our code. We've made our list item a pure component, so it only re-renders if its props change. React window will pass a stable index, and it'll cache while scrolling the style so that we don't unnecessarily re-render during a scroll. But in this case, we're also passing in our data. And actually, if we look back here in controller, we can see that more than just the list rows, but actually our flame chart and autosizer component are re-rendering as well. And that's because we're reconverting our data each time the width or the height changes. In this case, the height's changing. The data itself is stable, though. It's just this JSON that we pulled in from GitHub. So we don't need to pay the cost of reconverting that with the recursive function every time our component receives a new height or width. So we'll use some normalization here. So normalization is a technique basically where generally we'll use some sort of utility helper function that keeps track of, it remembers the parameters you pass to a function. And if those parameters haven't changed since the last time you called the function, it just returns a cached version of the previous value. And then if they do change, it throws away the cache, reruns your inner function, and then returns that new value. So I like to use a library called Normalize1. The reason for this is because it has a cache size of 1, so you don't have to worry about memory use sort of growing over time if your values change frequently. In this case, it wouldn't actually matter because our data value isn't changing, but in a real application it might. So let's go ahead and pull Normalize1, and then we'll use this to wrap our data conversion function. So now the first time we call it, we'll run this convert data function, but the second time we call it, unless data has changed, memWise1 will just give us the previous value without doing all of this expensive recursive traversal and object creation. So let's take a look at our app here and see what we see. Okay, so we're still re-rendering everything, which means we've missed something. So our list item takes a style, which I know React Window will properly cache, an index, which is stable and it's not changing, and then this data param, which is our list data. And this param, or sorry, our item data. And this param I'm actually recreating every time, so this is also not great for our pure component. So let's go ahead and memorize this too. We will make a new inline function here that takes list data and width and returns an object of the same shape as we were using before. And we'll call it. So now what's going to happen is our function will be rendered, and unless data has changed, we'll get a cached list data. And unless width has changed, we'll get the same width. And so our item data will also be cached and reused between renders. So let's try again. Let's resize the height. And cool. So now as we resize the height, you can see that at most we're only adding a new row or two. And when we're shrinking the list, we're not doing anything. We're just pulling rows from the list. But as we make the list a little taller, we'll maybe render one more row. So our flame chart component still re-renders itself, but its re-render time is now really fast. So let's maybe do another stash and compare. So we went from taking, let's say like 11, 9, 10, around 11 or so milliseconds every time we resize the height, to taking more like 2. So that's great. Let's make this memorize things. That's great. My previous commit messages are super detailed. Let's see here. How much data is still acceptable to memorize? Perhaps in some cases there will be too much memorized data. Yeah, this is a great question. So this is the reason I mentioned that I like using memWise1 instead of Lodash memWise or another memWise library. By default, Lodash memWise has an infinite cache size, which means if you call it with a value that changes each time, your memory usage is just going to go up over time. memWise1 only has a cache size of 1. So if your data changes frequently, you might not actually be getting much advantage from the caching, but you at least won't have memory leaks, essentially. I think Lodash memWise does let you provide your own caching mechanism, which you can use weak map, for example, if you're running in browsers that are new enough to support that, which can help mitigate the memory usage a bit. But in most cases, I think memWise1, or maybe if there was a memWise2, and I don't think there is such a package, but something like that could also be useful in a case where your value switches back and forth between a small number of values. Yeah, so I think I might actually wrap it up here, but I won't, because I know something that we could do to make things a little faster, but I think it gets kind of pretty involved. So if we look at the profiler now, we can, well, let's do a fresh profile. If we look at the profiler now, we'll see, like, I scrolled a little bit, I resized the window, with the exception of this one. So that's interesting. I'm not sure why we had that one long tail. But in general, we're pretty fast, with the exception of our initial rendering, because we're doing this recursive crawling of our input data, and we're changing it to a different data structure, and then we're also rendering all of our rows. So there's a lot of work going on this first time, and maybe that's okay. Maybe it's not actually a problem, but maybe it is. And so one thing we could look into doing would be to sort of lazily convert our data. So the way that React window works, again, we're only showing, in this case, to fill this window, we're showing 3, 4, something like a dozen rows. So we could get away with only going down a dozen levels deep and converting the data for our tree and then waiting to convert the rest until we need it. And this is actually a technique that I used in the flame chart that I wrote for DevTools. So if you're interested in seeing it, this technique, I would point you to let's see. I would point you to here. Basically, I'm using a couple of lazy maps, and I'm sort of just in time doing the data conversion as you scroll down. This would probably be overkill for this chart because it's not very big, but for a really huge chart, it might actually be worth doing this and sort of amortize the cost of converting on over time rather than paying it all up front. But that I think is probably a little more involved than I want to go into for a live stream. But while I'm watching the chat, if you have any questions, I'd be happy to answer them now. And if not, you can always hit me up on Twitter afterwards. I will say while I'm waiting to see if there's any new messages that I'll be updating the description of this live stream as soon as we're done to point to a GitHub repo that has the code that I've written so far. So if you want to play around with it yourself, you're obviously welcome to. Cool. I think that will wrap it up then. Thanks so much for those of you that are watching. And like I said, if you have feedback or questions or if something didn't make sense, just shoot me a tweet. And yeah, thanks for watching. And now I will awkwardly try to figure out how to stop the presentation. All right, see you all next time.